So I'm recording this just so everyone knows. All right. So we're going to talk about something that you probably have seen in the past. We're just going to get maybe more of an idea or name, I guess. And so today we're talking about arithmetic sequences. And tomorrow we will finish them up, and then we're going to do something that's called a series arithmetic. So arithmetic sequence, the first thing we need to do is just define what they are. So could you predict the next number? What would it be? 20, yes? How'd you get from here to here? Here to here? Here to here? Now, can you predict the next number? What would it be?
29.
What did you have to get from here to here? What did you do?
7.
2. Is there a pattern here? Could you create, hold on, watch this. Could you predict what the next one is? This is not an arithmetic sequence. It is a pattern, but it's not an arithmetic sequence. What can you see the difference is from the one I gave you, which is called, the first one is called an arithmetic sequence. And what's the difference between this one? Chloe?
They increase by the same number every time.
Yes, you guys are both saying the same thing, just said it differently. Perfect. In a sequence, it has to be going up by the same number every single time. It has to be +2, +2, +2. So, are these both patterns? Yes. A sequence is a special type of pattern in which you are adding, please make sure you hear what I said, you're adding to get to the next number. Yeah. Is this an arithmetic sequence?
No.
He says no, because you're not adding. But we're in bigger school now. How can I subtract by adding? By adding a -5. So what is my common difference here is a plus a -5. You can do it. It's still adding. It's adding a negative number. Okay, so we always do arithmetic sequences by adding, and the number that you're going to get to the next one is called the common difference. And we represent that with a D. This really means common difference. Now, what's the common difference for this one? No. What's the common difference? -5. Remember, we got to be careful. 5 and -5 are not the same number, and I'm being hard on you because we got to start seeing that. Because when you say that out loud, that's what you think, and that's what you write on your paper. Does that make sense? So we got to get away from that. What was our common difference for the first one? 2. Does everybody see that so far? Yes or no? Okay, what else I'm going to do today is I need you to start understanding math was never, ever, ever created by any man. Okay? Let me explain that to you. I don't care how you believe or what you believe how the earth was created. When the earth was created, math was instilled in it. That exact moment, math was instilled. It's like, do we say that so-and-so Christopher Columbus, which we're not going to get into that whole argument. Do we say he discovered America, or do we say he created it? Discovered it. Why? It's not like he was out in the middle of the ocean with a boat full of sand, filling it up and making some land, and he made this land called America. No, it was already here. Right? I understand there was already people here, so why do we say he discovered it? Anyways. But when something is already there and you're the person who kind of unlocks it, you discover it. We are discovering math. It's already here. It's already around us. And the more we discover about it, the cooler things that we get. If you go back, there's a Disney ride, and it's the at Epcot. Do you know that huge globe? First off, my friend thought I'm not kidding. He thought all of Epcot was inside the globe. Yep, that was fun to make fun of him. Because now every time we go or we see a picture, I'm like, look, it's all of Epcot. Epcot's massive, by the way. We've never been there. It's huge. No way could have fit in that. But that ride is a ride of journey in time. And it talks about, basic man was just trying to live. Basically, all they cared about was food, water, and shelter. That was it. That's all they could really do. Then they started learning how to write or to describe things. And then they got better at their hunting because they could pass on information. I could teach you to do this. And so they were able to start teaching and learning. So they didn't have to recreate the wheel, pun intended, because that's kind of what we talk about, cavemen and making that. They didn't have to recreate the wheel every single time they went out to hunt. They already knew it, right? If you keep going on it, all of a sudden they talk about math in this ride. When you see math happen, boom, that's when the explosion of technology, all these cool things that we enjoy today, takes off. It all has to do with people actually truly understanding math and what it can do. It's why a plane can fly, right? Think about it. It's how we build roller coasters without killing you. Because they could build and absolutely can build a roller coaster that when they came back, everybody would be dead. It would pull too many G-forces. You wouldn't be able to breathe. Everyone would die. Do you think that would be a good roller coaster to create? No. So what do? They use math. They use programs. Yes, the computer does it for them, but there was someone who put that formula into the computer, right? Computer's only as good as the person who designs it. Someone designs that, says, hey, this is what the formulas are and how we create this. And then they can calculate it so that they don't waste millions of dollars and kill people by just trying it, right? So the better we unlock this math, the more we are capable of doing cooler things. The more math we unlock, maybe one day we can actually get to Mars. Maybe one day we can actually teleport. The more we unlock, that's going to happen, right? If you think about it, seriously, all the science things that they talk about, flying things and all that, now they're realities. So don't put anything out of the realm of possible, because it all used to be science fiction, and it's happening now, right? And it's only happening with the more we understand our Earth, the way that physics, chemistry, which are all part of math too, right? Math is the science of those. It works with them. So today we're going to try to be like one of those people and discover where this thing called an arithmetic sequence came from, because there's a formula for it, but you're going to come up with a formula. I'm not going to give it to you. Okay, we're going to see where this formula comes from. So here we go. Think about this. How in the world did you get to the next term? What did you do? Add 2 to what? Add 2 to the 16, correct? And then you got 18. How would you get to the next one? So what are you using? So by the way, this is called term. This is a term. This is a term. This is a term. This is a term. And this is a term. But if I told you, hey, look at this term, what's the problem? Which one do you want me to look at, Mr. Martin? So here's how we came up. Oh my gosh. Here's how we came up with solving that. We call this A1. What do you think the 1 represents? First term. A, because it's arithmetic. Later on, we're going to learn about one that's called geometric, which is you multiply to get to the next terms. That's going to be later on in the year. It's called a geometric. What do you think we use to label them? G1. So, I mean, does it really have to be A? No. Why do we call it A? Just because it reminds us that we're in an arithmetic sequence. So what would you call this one? A2. What would you call this one? What would you call this one? A5, A6. What if I don't know what term I want to talk about? What if I'm talking about some arbitrary term? AN. It's just a term. So it's like I could be term 100. Right. It's just the variable, and we use n for that variable when we do this. Kind of like we use x most of the time for that. We use n for this. AN is whatever term we want to talk about. We want to talk about the 100th. We put 100 in there, and it becomes the 100th term. If I want to say, wait, I want to talk about the 60th term, I put a 60 in n's place, and it becomes the 60th term. Does that make sense so far? All right, so here's what I need you to do. I need you to think. Yes, it is called Spaceship Earth. Do you like that ride, Jaden? Sorry, I didn't have that pulled up. Oris, what were you making that face for? You can talk, you can unmute. I got you. I got a lot of them, Oris. You guys are in trouble. That's bad. All right, so AN. Let's talk about how I found the next one. How did I find this next term? But we're not going to use, we're going to use generic terms. So here's what I mean by that. What if I wanted to find A7? You would go to A6. Perfect. And you would add, well, what did I define? I don't want to use 2 because it's not always going to be 2. What will we add to it? What did I call that? What did I say 2 is called?
The common difference.
The common difference. And what did I say we use as the common difference? D. Do you remember me doing that? So what if I wanted to find a 100? You go to A99, which means the term in front of it, right? This is the 99th term. Is the term 99? No, not necessarily. So you see how that's kind of hard to, you need to make sure you understand. There's 2 numbers that are representing one thing. Like right here, I can call that term 1, which describes what term it is, not what the actual term is, and 10 is the term. Do you get what I mean by that? Don't mix those up. So I'm going to go to the 99th term, or the term in front of that one, and I'm going to add the common difference. Yes? So let's go real generic. Think more along this line. Instead of A100, do you see how that's really specific? What if I wanted AN? How would I describe that? Nope. How do I, what? AN. No. How did I get from 100 to 99, guys? What did I do? No. How did I go literally from 100 to 99? You subtracted how many? So if I'm at AN, there it is, AN minus 1. What does AN minus 1 really just represent? The term in front of it. Meaning, if this is the 60th term, this is going to be the 59th. It just represents, so if I'm at AN minus 1 is just the term in front of that one. Does that make sense? Plus D. This is called the recursive formula. So this is called the recursive. We're going to talk, hold on, you're right with me. Here's the problem with the recursive. I'm at A6 here, right? Do I want to just keep adding 2 and adding 2 and adding 2 and adding 2? Because the problem with recursive is you have to know the term in front of it to find the term you want. Meaning, if I want the 100th term, I need to have the 99th term in order to find the 100th term. And if I only like have A6, I don't want to sit here for days and add 2 to it to figure out, because technically they could ask me to find the 1000th term. And I don't want to sit here forever. The 2000th term. Take all class period. I'm going to give you another formula for that. We're going to come up with that one. But first, what I want you to recognize is, what is the recursive formula? When is it good to use?
Arithmetic.
Yeah, it has to be arithmetic, but when do I want to use this one?
When you're going backwards, like when you're decreasing numbers.
You don't have.
When you're trying to find a certain like term, I want to say is what it's called.
Yeah, but when do I want to use this one?
For larger terms?
I know I don't want to use this one for larger terms, Annabella. I mean, let me take this back. Here's what I'm looking for. You only want to use this one if you know the term in front of it. Like, would it be okay for me to find A7? Why? Because I know A6, it's going to be real easy to find A7. If I told you what the 99th term was, and I told you the common difference, would it be okay to use the recursive formula to find the 100th term? Yes. When do we not want to use the recursive formula? When I don't know the term in front of it, or even close to it. I don't want to use the recursive, because the recursive has to have the term in front of it, and then I can add the common difference. So when's the recursive good? When I know the terms in front of it. When's it not good? When I don't know them. Kind of making sense? You're on the right track. We're going to come up with that next one. She's already tried to come up with the next formula, and you're on the right track big time. So how do I find, well, again, some man did not come up with this. They just discovered it. They just saw the pattern and go, hey, this is what's happening every time. I just use the term in front of it and just add the common difference, and boom, I've got the term I need. So how do we find, like, let's say we wanted to find the 100th term of this. Yep.
You want like 100 term and it's plus 2 when you do like 2 times 100 and then what?
You're on the right track. You are on the right track. But here's the problem. Whoa, I can't add, that's the problem. Some of you guys are already getting it. This is the first term, right? So this is A1. How many common differences was added to this one to get to the first term?
5.
How many common differences did I add to get to the first term? 0. The common difference was never added to the first term. It's just the starting point. It's just the number. This is what you're starting on. There's no common difference that was added to that.
So how it always says no common difference.
For the first term, no common differences. It's just the first term. What term is this? The second term. How many common differences was added to it? What term is this one? Third. How many common differences was added to it? Are you starting to see something, hopefully? This is the fourth, but only 3 common differences were added to it. And finally, we're going to talk about this one. This is the 5th term, and only 4 common differences were added to it. Basically, here's what I'm telling you. It's like I started with the first term, and I added 2 4 times, and that's what got me to my 18. Does that make sense? What, since we're adding, this is why it has to be the same number every single time. Has to be the same number that you're adding every single time to be an arithmetic sequence. What is repeated addition called? It is called multiplication. In fact, really, instead of seeing this as 2 plus 2 plus 2 plus 2, what could I rewrite that as? 2 times 4. You with me? And this was 18 equals 10 plus 2 times 4. Let's try to come up with a generic form for this then. Meaning that AN1. What if I wanted to find some term, whatever term I want to use? What will I always start with? What did I always start with? But it's not going to be 10 in every example. It's the first term. So I'm going to always start with the first term. And then I'm going to add. What is the 2? The common difference, yes? Remember, this is A5 times n minus 1. How the heck did she come up with that? You are always going to have the common difference added that many times minus 1. Nick, that's kind of what you said too. You said if I'm on the 100th term, I'm only going to have added 2 99 times. Because I don't do it because n is the 100th term. I don't remember, the first term doesn't get a common difference. So it's always, the term is always 1 ahead of how many common differences I've added. Right, because it's like I'm on the 100th term, but I only got 99 probs, but a girl ain't one. Say that again.
Okay, so n means 10 in this case.
Not necessarily.
Well, I mean like.
So let's say I want the 100th term.
Yeah.
That would mean that I'm saying n is 100.
Yeah.
So I'm finding the 100th term of this, and we're going to use this pattern right here. What is A1? So A1 is 10. Plus, what's the common difference? 2. And I'm only going to multiply 2, n minus 1. So I mean, I can do this, 100 minus 1, but that's really 99. And the reason I'm doing that is because, like we said, the first term doesn't get a common difference. If you look, this is A5. It only got 4 common differences added to get to that. So the 100th term is only going to have 99 common differences added to get to it. Because the first one doesn't get a common difference. That's where this guy came up with this formula. That is a formula, and that is called the explicit formula. Like your music. Some of you. Yes? Yep, 99 times 2, get that? Yep, that will be the 100th term. Which, by the way, we can do this, right? 2 times 100 would be, but I don't have 100 of them, I'll hit 99, so if you take 2 away, you get what? And then 198 plus 10? So the 100th term should be 208. By the way, do you see how I'm showing you how to try to use your brain instead of using a calculator? Because I want you to try to do that. Now, I would try to encourage you, like if I'm on homework, for sure do it in your head. Practice it. Maybe on a test, go ahead and just use your calculator because you don't want to make a silly error. But again, you should know number sense. We've kind of talked about that. Don't just trust the calculator because sometimes we get fat fingers. We accidentally hit 2 buttons instead of 1. Don't just trust the calculator. Have an idea of what that number should be. Don't just trust the calculator. Does this make sense so far?
What does N stand for? I'm really sorry.
N stands for whatever term I want to find.
Okay.
So if someone said find the 48th term, my 48 would go here. The N is whatever term I want to talk about. So how'd I get what? I just plugged in for the formula. I did 2 times 99 and then added 10. This will be what your homework will be based on. But that's so that's the common ratio. That's geometric. That's the one where you have to multiply by the same number, but we're not doing that one right now. We're only doing adding for this, even this chapter. We won't get into it. It's another chapter that they throw it in. What? Yeah, you will. I know. Dude, as soon as the bell rings. I don't, it's not too much. It won't take forever. I understand you guys have games and stuff, so I don't give you too much, but get it done right as soon as your bell rings so you understand you have something and it's fun, right? So get your homework done first. Right when you get home, do it. Or go to Miller's, I got work I gotta do it in there. Because do you guys go home or you have team meal and stuff? None of your friends' house do this. It should take more than 30 minutes. All right. So first thing you're going to do is ask if it is a recursive or if it's a arithmetic formula. So they're going to give you things like and the question is it an arithmetic sequence? Yes or no? And your answer would be no, it's not. Okay. Then they might give you something like what? Is this an arithmetic sequence? What's the common difference? Common difference is 3. So these are questions they could ask. They could ask, is it 1? And you would say yes. They could say, give me the next 3 terms. Please, I need you to start using these big words. If they ask you to give me the next 3 terms, which formula would I want to use? Would I want to use the recursive or the explicit? Why would I want to use the recursive? Because I know this one right here, and all I'm doing is finding the one after it, the one after it, and the one after it. No, for me, if you just give me those numbers, I'm cool. Does that make sense? It's the concept, the understanding, the recursive. He's using the one in front of it to get to the next one. This one? No, it's not. Nothing. Yeah, there's nothing. There's no pattern in that one. Just because, and be careful with patterns because it doesn't always have to be like this. That doesn't look like there's a pattern, but what's the pattern? These are all right here. Between here's 4. Because then this only increases by 2.
What is this?
These are prime numbers.
Oh,
So it could be just a list of all the primes. That's still a pattern. I'm listing all the primes.
Oh,
Prime numbers are numbers that only have. But so patterns, see the thing with patterns is it doesn't have to be adding the same thing every single time. It just has to be something that I can predict the next one, right? With arithmetic, it has to be the same number every single time and adding. So they could say, okay, I want you to find the 50th term. So I wouldn't want to use the recursive. I'd want to use the, and so this would be if I said, Josh, if they said find the 50th term, they just told me what? What is that really 50 going to be? My n value. My n value is going to be 50 equals, if you remember, it's a1 plus the common difference n minus 1, right? So it's going to be 12 plus, what's the common difference? 3, and then what? 50 minus 1. So then you just do 49 times 3 and then add 12 to that, and that would be your answer. And that would be the 50th term. Does that make sense? Hold on. Word problems, don't freak out about them. Translate them to real, like, math. If I said a high school auditorium has 18 seats in the first row, what does that mean? It's telling you A1 is 18. That's the first row. It's the first number in the sequence. And I said, and 26 seats in the 5th row. What does that mean? A5 is 26. What did they not give you in this problem?
2, 3, 4.
They didn't give me 2, 3, 4. They didn't give me the common difference. Now, it technically, because it's only between 1 and 5, could I just use my logic to figure out what the common difference is? But what if this is like A1 and but 100? You're not going to be able to count it. So this is the process you use. Even though I'm using small numbers, this is the process. No matter what happened, I could use. So here's what I know. Remember my explicit formula? Crap. Remember my explicit formula? It's an, which is any one I wanted. I just used a1 plus the common difference and then n minus 1. Well, what information could I fill in over here that would allow me to work backwards so I could solve this? Because that's what I need. I need my common difference.
A1.
Okay, A1 would be what? 18. Plus, what's some other information I know?
oh, we know 18 again.
No. A5 is what? So couldn't I put a 26 here? And then what would my n minus 1 be? It wouldn't be 26 because 26 is that in the place. Remember, n is talking about what term number is it? It's the 5th term, so I put a 5 in there for my n minus 1. Do you see where you can make mistakes? Be careful on that. And then I can use my math to work backwards. 5 minus 1 is 4, or 26 equals 18 plus, change that to 4D instead of D4. I minus 18, this is all algebra 1, right? 8 equals 4D, divide by 4, divide by 4, 2 equals D. So for this question, they asked me to give the explicit formula for it. Well, for the explicit formula, all I need is A1 and D. They didn't give me D. So I used the information they gave me to solve backwards and get D. And now then I can give them the explicit formula, which is AN equals 18 plus 2 times n minus 1. And there's my explicit formula for that question. So all they did was give me this information. They asked me for the explicit formula. For explicit formula, I need A1 and D. They gave me A1. They didn't give me D, but they gave me a way to solve for D. Does that kind of make sense? Yes. Because I could put A5 there. But remember, when I do the explicit formula, it gives me the value of what A5 is. A5 is the fifth term. What is the fifth term? 26. That's what all this will add and subtract to. So that's why I put a 26 in there. Bye guys, have a good day. Your homework is in Portal.